Hi, I'm Dennis diCicco, Senior Editor of Sky and Telescope magazine, and I'm here in Suffern, New York for the 2013 Northeast Astronomy Forum, NEAF. And right now I'm speaking with George Whitney from the technical support staff at Astro-Physics. I think readers of the magazine are well aware of Astro-Physics. The company has been around for more than 30 years. They have been building high-end refractors and telescope mounts during that whole period. And if you look around and see some of the finest astrophotography that's done today, there is a huge chance that either a telescope or a mount or both that is from Astro-Physics is involved with those images. So George, you've got some new equipment that you're introducing here at the show. You want to tell me a little bit about this?
Yes, Dennis. This is our newest mount, the 1100 GTO. It is a mount that we've incorporated all the very, very latest of our innovations and have tried to maintain our philosophy of portability and modularity to our mounts, similar to many of our other mounts.
All right, now I know in the Astro-Physics line that the numbers sort of refer to the size of the mount. This is the 1100. This is a replacement for the older 900 GTO mount. Is that correct?
Yes, that is correct. As opposed to a larger version of the 900 mount, it actually is more of a smaller version of our 1600 mount, which is our flagship, in that it incorporates all of the latest changes and newest innovations.
All right, want to tell me about some of those?
Yes, one of the most obvious innovations is the fact that we have increased the worm wheel size. It now is the same worm wheel size as the RA.
Both gears, the RA and the deck gear, are the same size.
Yes, they are. They're both the same size, which has increased the amount of capacity of the mount dramatically from the 900.
How much weight will this carry?
We've increased the capacity of the mount, which is seen in two different ways. Not only does it hold a heavier payload, but it also means that longer refractors can be used on it. That is what's referred to oftentimes as the moment arm.
The moment arm. Now, I can see a mount like this would go very well in somebody's observatory, permanently mounted and set up. But it also looks like this is made to be portable. Is that right?
Yes, that is correct. One of the traits of our mounts is that they have the capacity to be broken down into smaller sections for easy transportability and setup. This mount, for example, as with all of our mounts, separates at the deck and RA axes. By simply loosening these locking knobs, Dennis, you can lift the entire deck axis off the RA axis.
So it breaks down into various pieces. What's the heaviest single piece?
Well, the RA axis, that would be the heaviest. It includes the base. It is a mere 24.5 pounds. It's very lightweight.
Easy to manage, and the deck shaft is even lighter.
Even lighter at 17.5 pounds.
So one person could easily set this up in the field by themselves.
Absolutely. In a matter of 10 or 15 very, very casual minutes, a single person can easily assemble it. You simply place the pier and the RA axis drops in, ties in by these 6 locking screws, and then the deck axis slips on a dovetail system locked in by these 2 locking knobs. The counterweight shaft screwed into its location, counterweight's placed, and saddle plate put on top.
You're ready to go.
Set to go.
At that point, you're ready to do polar alignment.
Yes. One last piece that must be remembered is that because this mount now incorporates internal wiring and allows pass-through wiring cabling, you must attach the cable that is in the RA axis to this socket.
Okay.
That is now included through the mount.
Okay. You just brought up a very good point. You can do pass-through cabling in this mount.
That is correct. As with all of our new mount designs, cablings can be passed through, entering the base of the RA axis through this plate in place right now. It can be removed and the cables pass through. They then travel up through the RA axis, which then take a bend, come up through the deck axis, and out through these cabling ports front and back. To make it easier to get the cabling through, before you actually would attach the telescope in place, this top cap is also part of a dovetail system. It's very similar to what was on the attaching the deck axis to the RA, also attaches the deck cap to the top of the deck axis. By simply loosening these 2 knobs, the cap can be lifted off allowing very, very easy access for cable pass-through. That's one of the innovations that is being passed through all of our mounts.
So that's great. It makes it, if you've got a CCD camera or other electronic equipment on the back end of the telescope, by having the wires run through here, they're not likely to snag and catch on anything as the telescope slews around during the night.
Yes, that is one of the very, very nice features of the internal wire cabling, plus the ability to pass through cables.
All right. So I had started to ask you before about the polar alignment with the new polar alignment system. You want to show me a little bit about that?
Yes, we would need to come to the back of the scope. And here you see our new right-angle polar scope. There are many new innovations to this. This is a recent design by Roland. It not only increases the focal length of the optics more than double, which increases the resolution of the polar scope, it also, for us old timers, makes it very, very convenient for viewing because of the right angle feature. No more broken necks looking up through a polar scope.
Just looking right down in a right angle eyepiece.
Absolutely. And in addition to that, there's a unique reticle system which simplifies the whole polar alignment process and allows it to be done during twilight.
It's an illuminated reticle, obviously.
Illuminated reticle, but also we have apps for the iPhones, for the Windows Phone, for the coming very, very soon, the Android phone, and also we have an app which is part of the program, the ASCOM, the AP ASCOM V2 driver as well.
So that runs on a PC?
Yes, that runs on a PC.
And these apps generate a position for the star that you place on the reticle, given your date and time where you are. You put that on the reticle, move the telescope around, and you're polar aligned.
Simply referring to the iPhone program or any of the other ones that are available, you simply locate Polaris, which can be done during twilight, as I mentioned, on the exact spot in the reticle, which is duplicated on the iPhone apps or the other Android, what have you, apps.
Right. So how easy is it to move the mount around to get Polaris to be right where it needs to be on that reticle?
Dennis, is a very, very simple process. In fact, we've made some tweaks and modifications to the azimuth altitude system of our mounts to make it yet even easier. The azimuth itself is been shifted from the front of the mount to the back of the mount, as you see here. So you have easy access while looking through.
It's right, you don't have to reach around the mount. You can be looking in the eyepiece and you can be twisting these knobs. And that's the azimuth adjustment.
That is correct. So very simply, very conveniently, very easy. Now, we still have to reach around to the front for the altitude, of course, but even that has been simplified. Let me show you how we've modified the front of the mount. We've completely redesigned the entire altitude system here. To make it very fast and convenient to change between different latitudes, we now have a slotted system in the front, which allows the altitude bar to be dropped into any of the positions necessary based upon the latitude that you're at. Then we've also changed the altitude knob to add the captain's wheel feature so that you can have a very easy time making the tweaks and turns. Please note also that this now has the ability to move in a latitude from 0 all the way up to 78 degrees, which covers virtually everyone who's going to be using one of these mounts on the face of the Earth. From
so you start right at the equator all the way up to the Arctic Circle.
That is correct. All the way, in fact, Dennis, we even have a customer down in Dome C in the Antarctica at the very highest of altitudes. So that works perfectly for them. Not only that, but this mount could be very quickly switched into an alt-as position.
You can almost use it at the pole.
You could use it at a pole or for specialized uses and purposes.
Right. And I see what you mean by the convenience, because I could be viewing in the eyepiece, adjust the azimuth here, and reach around very easily, and that's a big captain's wheel knob. I could be turning that to adjust the altitude while I'm looking into the eyepiece.
Yes, can I sell you one?
Well, I'll tell you, I already have the app on my phone, so we're halfway there.
Excellent. Okay, well, we'll package one of the first ones up for you.
All right. So I see there's some other new features here. It looks like the Finder bracket is pretty sophisticated. You want to tell me what's going on with that?
Oh, Dennis, it's more than a Finder bracket. In fact, this is a piece I'm very, very excited about. I have a great deal of partiality to it. This is how we convert the existing Finder which we have into a guide scope bracket. We've done some very, very unique changes to it to give it rigidity, non-flexure. If you notice here very carefully, the bar which ordinarily would connect the Finder has been lengthened dramatically. That provides the ability to shift it for weight and balance, but much more important, it allows this third ring to be put on. That third ring is the key to what makes this a very rigid, non-flexing structure. It anchors and secures the focuser, the draw tube, at a point well back so that the camera itself cannot move up or down in a flexing fashion. The total rigidity has been increased.
All right, so I see the two things you mentioned. So there's a focuser here to adjust the focus on this guide scope, and you've got your little CCD guider camera in the back here.
Yes.
So it's a very nice system. Just plug and play and start doing your auto guiding.
That's pretty much it. You have a coarse focus, you have a fine focus, you have the balance. One additional feature, we've expanded the length of this block in order to, again, add to the robustness of this structure. We've removed the felt from its normal location underneath the base and have substituted material that allows it to be much more rigid and non-flexing in its attachment at the scope itself. Now, why do we attach it at the scope? Why not simply mount it on top of the rings? Because it is very, very important for a guide scope to be guiding with the telescope, but not the rings. And this, by attaching it to the actual telescope, as you see here, allows it to move with the scope should there be any flexure from the rings or the felt that is holding the actual scope. Microscopic, but important.
Very nice system. All right. I noticed from the angle that we're looking here, I noticed this little black box on the back of the polar axis. What's this all about?
Dennis, this is part of the absolute encoder system, but I can show you it much better on the 1600 mount.
All right, let's go take a look at it. So we've got the 1600 mount over here with the absolute encoders on it.
Dennis, the absolute encoders, this is the one on the deck axis, this is the reader. The actual Renishaw encoder is inside the axis here. There's one also located on the RA axis.
So what are the advantages of these high resolution encoders?
Dennis, absolute encoders do several different things. One is they virtually eliminate periodic error down to a small fraction of an arc second.
That's on the RA drive.
On the RA drive. And on the deck axis, they zero out backlash. It just is gone.
No backlash when you're guiding and the telescope is differentiating between moving north and south?
None whatsoever. In fact, if there is a small jump in the star's position due to, say, a twinkle in the air, the next move brings it back to the exact spot where it was.
When you're guiding?
When you're guiding.
Any other advantages of the encoders?
Yes, they provide software settable limits and home positions. The limits can be contoured with our software to be very, very specific to your telescope, your camera setup. Your movements can glide around any small difference in the profile of your mount or pier setup for very, very careful limits.
So in other words, when you've got a camera on the end, the telescope knows where not to go so that it won't bang into the pier or hit something else.
Exactly, and if you have an offset filter wheel, even that small amount can be compensated for.
With the encoders. So now one of the big advantages of an absolute encoder is when you power up, the telescope automatically knows where it is. You don't have to start from some known position. The telescope knows because it's an absolute encoder.
True. There is absolutely no way, I hate to use that word absolute so frequently, but there's absolutely no way that you can get lost.
All right. You mentioned software. That brings up a good point. Can you tell me a little bit about the software that you can use to control the telescope?
Yes, but I'd really like to introduce you to my colleague, Howard Headland, who is also in the technical support staff with me.
All right. Let's go meet Howard.
Well, hi, Dennis.
Hey, Howard. George tells me you're the guy that can tell me all about the software.
Well, I can certainly try. APCC, which stands for the Astro-Physics Command Center, is the software we have developed for remote control of our mounts. It provides full mount control for all Astro-Physics go-to mounts.
All right. Now you say remote control. I'm assuming you could be sitting next to the telescope with the computer controlling it, or be elsewhere.
That is absolutely correct. This acts as the final step in any communication between a computer anywhere and the mount. So it could be a remote computer 100 miles away. It can be the computer that's 4 feet from the mount as we are right now.
All right. So give me an overview of what it can do.
Well, it provides virtual ports so that you can connect other software funneled through APCC to talk to the mount all through a single serial port. One connection is all you need to the mount. It has numerous features with it. A couple of the most noteworthy are a horizon limit, which is fully customizable and settable by the user. The mount will stop tracking when it reaches your horizon and will do whichever option you have chosen. We have meridian limits. One of the great features of the Astro-Physics mounts is the ability to track past the meridian or to start an image ahead of the meridian. And this is customizable for your system so that you know at what declination you can go a certain distance ahead of or behind the meridian.
To prevent from having the telescope or cameras from banging into the pier or whatever.
The whole idea is we want to maximize the use of the capability without having any accidents.
Right. And in some cases, the mounts have a full 360-degree rotation.
They do. You can actually image at certain declinations from horizon to horizon with an Astro-Physics mount.
Without having to flip the
Without
declination.
having to flip, yes.
That's a very unusual feature for German equatorial mounts.
Well, it is, but you know, our philosophy is why would you want to flip the mount and waste all of that time when your telescope is at the best part of the sky for imaging?
Excellent.
So then finally, really the other major thing is our Pro version has a pointing model. I'm actually running a point mapping run as we've been talking and accumulating all of these points for the mapping run. And when this is completed, we will be able to use the data acquired to create a model that will correct both pointing and tracking in both RA and declination.
So it gives you very high precision pointing.
Very high precision pointing and very high precision tracking, including calculations for atmospheric refraction and polar misalignment.
So that model gives you the ability to do very high precision pointing.
Yes, very high precision pointing and very high precision tracking. It compensates for atmospheric refraction, polar alignment, all of the other things that can ruin your pointing or your tracking.
And I noticed even while this is running automatically, there's this rather cool display here that shows you kind of in 3D where the telescope actually is.
That is one of the fun things about APCC, and it's also one of the valuable safety features because you can see, even if you're in a different room, where your scope is actually pointing.
Well, I can see that this is doing what appears to be a lot more than just moving the telescope and stopping. It looks like it is controlling the system or allowing the system to take the images and analyze them.
Yes, it is governing both where the mount is pointing, as seen by all of the dots, and then it is also taking the image, processing the image, doing a plate solve using pinpoint, and then taking the data and calculating the delta.
So this program will interface with any other program that uses ASCOM? That's cool. Are there any other features you want to tell me about?
Well, we have one more thing in particular. This includes the Horizons program, which provides custom precise tracking for comets and asteroids and other bodies that are not moving at the sidereal rate through the sky.
So you can actually get the orbital elements of comets and asteroids, feed them into this program, and the mount will track at the proper rate to follow the motion of that object rather than just the stars.
That is correct. The data comes straight from JPL, and we take advantage of the very precise custom tracking rates that are variable within an arc second or two an hour.
Wow, that is very nice. Well, that's all great stuff. I want to thank you very much for showing it to me.
Thank you very much, Dennis. Always a pleasure.
Well, pleasure talking with you as well. I'm Dennis diCicco for Sky and Telescope magazine here at the 2013 NEAF.